You are currently the only person in this conference.
Students, can you hear me? Can you see the screen? Students, can you hear me? I'll start in 2 minutes, Amma. I'm waiting for all the students to join. Okay. Okay, students, let me explain you. Students, first of all, sorry for the delay. Due to heavy traffic, I could not reach the class on time. Okay. Sorry, extremely sorry for the delay, students. And I want to start the class now. Now, see, students. Okay, we have studied about the. Now, see, students.
सर जो हम नॉमिनल शेयर स्ट्रेस निकालते हैं ये हम एमएम में ही होगा हमारा, इसको हम एमएम में निकालते हैं, ऐसे किसी सेंटीमीटर में भी हो सकता है।
You are telling nominal shear stress usually will be Newton mm square, or it can be Newton per meter square. It cannot be Newton because Newton per meter square is Pascal and Newton per mm square is MPa. Usually, this is the notations they follow. Amma.
ओके सर।
Now, see, students. First of all, We will discuss about a member. What is a column? Anyone, can you tell me what is a column? A column is nothing but a structural member. A column is nothing but what, sir? A column is nothing but a structural member. What is a column? A column is nothing but a structural member. Now see students, how this is the structural member. Actually, suppose if you see here, there will be a load coming from the beam, and due to the soil pressure and due to the footing also there. So usually column is said to be called as a compression member. Sir, this is a famous question. What is a column? A column is a compression member. Sir, similarly, you might me ask me what is a tension member? See students, a tie. If you see a tent, you will tie this to a rope, right? Like this. So this tie is called as a tension member. I hope you are clear. So what is a column? A column is always a compression member and a tie is always a tension member, right, my dear students? Now, see here students, I want to tell you one important thing. We have a concept called lambda. What do you mean by lambda is slenderness ratio. We have a concept called lambda that is known as slenderness ratio, or you call it as, what is the definition of slenderness ratio is? Slenderness ratio is defined as the effective length upon, it is defined as the effective length upon least lateral dimension. You can write as effective length upon least lateral dimension. If effective length upon least lateral dimension is less than or equal to 3, if effective length upon least lateral dimension is less than or equal to 3, then it is said to be pedestal. My dear students, pedestal is also a compression member. If anyone asks you what is pedestal, a pedestal is also a compression member. Now you will ask me, what is L effective or effective length? Sir, effective length is nothing but the distance between points of zero moments. See students, effective length is nothing but the distance between points of zero moments. Effective length is defined as the distance between points of zero moments. Suppose, see students, suppose you are telling the distance between points of zero moments. Suppose, see students, here I have taken one important thing. Suppose if I consider a simply supported beam. In simply supported beam, the bending moment diagram will be here like this. So in this case, L effective will be equal to L. Suppose if I take a continuous beam here, okay, now the bending moment will be something like this, hogging, sagging. So here L effective will be equal to 0.707 L. Now immediately Rohit will ask me, sir, what do you mean by least lateral dimension? Suppose if I consider a column here, this is the dimension of column A and B. Out of these two, whichever is the minimum will be the least lateral dimension. Any doubts in this, students? Now see, if effective length is between, if the effective length is between 3 to 12, if the effective length is between 3 to 12, or effective length by least lateral dimension is 3 to 12. If it is between 3 to 12, what we have to tell student? Then it is what? Can anyone tell me? If the effective length is between 3 to 12, then what it is called? Anyone? Very good, very good. Then it is called as, then it is called as what? Then it is known as short column. Then it is known as the short column. So if the effective length is between 3 to 12, then it is known as what, sir? Then it is known as short column. Now, short column, how does the short column will fail? If anyone asks you, how does the short column will fail is, short column fails by crushing. Short column will fail by what, sir? Crushing. Similarly, if the slenderness ratio is greater than or equal to 12, then we say it is a long column. Then we say that it is a long column. So here, my dear students, here I would like to tell you How does a long column will fail? If I tell you, how does a long column will fail? How does a long column will fail is, long column, if I see here, how does a long column will fail is, long column will fail by buckling. How does a long column will fail is, long column will fail by column will fail by what, sir? Long column will fail by buckling. See, actually, what is long column? Short column fails by only crushing, I'll tell you. Amma. See, actually, there is a huge force applied here and huge. Sir, suppose if you are telling a UTM machine, you will take by a cube. A cube is subjected to what, sir? Compression. Then what will happen? This will it will crush. But if you see a electrical pole or anything, if you do apply the load, it will get buckled like this. Are you getting me? Sir Ashavani, I'm getting you. If you see a electric pole, if you try to apply the compressor load on both sides, the electric pole if this is the electric pole, suppose this is the electric pole, it tries to bend in this way. This is called buckling. But when you see short column, as the length is less, you are applying a compression load, then it will break. A simple example like cube and a electric tower. Clear, sir? Now see, student. I hope you are clear. Next. Now let me explain you what do you mean by minimum eccentricity. What do you mean by minimum eccentricity? What do you mean by minimum eccentricity? What do you mean by minimum eccentricity for axial load? What do you mean by minimum eccentricity for axial load? See, students, actually, suppose, see, why do columns are always designed for minimum eccentricity, sir? Sir, suppose axial load means if I consider this as a new section, the load is supposed to act here. But due to unskilled labor, or if the labor has done any mistakes, or if you have done anything small errors due to the placing of reinforcement, or any mishappening, this column might be subjected to some, the load might be here. You will think that it is axial load, but it will act as some eccentricity. Are you getting my dear students? Due to human errors or by mistakes, every column should be designed for minimum eccentricity. So according to the code, you can write here all the columns. Sir, this is the important question they can ask you in columns. All the columns are designed for, you can write here, all the columns are designed for, all the columns are designed for minimum eccentricity. All the columns are designed for what, students? All the columns are designed for minimum eccentricity. So here, when you see what is the formula for minimum eccentricity is, minimum eccentricity is equal to unsupported length upon, minimum eccentricity is equal to unsupported length upon, minimum eccentricity is equal to unsupported length upon 500 plus least lateral dimension by 30. This is an important formula. Immediately Rohit will ask me, sir, what is unsupported length? Sir, unsupported length by least plus least lateral dimension by 30. So let me explain you what is unsupported length and all. Suppose, see student, if we have a column here, the column is, there is a beam here, okay? Now this entire thing is an unsupported length, right? So unsupported length if you take it as 3 meter, you cannot take 3 by 500 here. Here 3 meter means you should take it as 3000 mm. So what is the, suppose if this value is less than 20 mm, suppose whatever the minimum eccentricity you have calculated is less than 20 mm, remember my dear students, we have to adopt the minimum eccentricity as 20 mm. Then in that case, you have to adopt the minimum eccentricity as how much? You have to adopt it as 20 mm. So my dear students, when I talk about the minimum eccentricity, all the columns are designed for minimum eccentricity. There can be an error due to the unskilled labor, or due to the application of load, or misalignment of steel, or improper reinforcement. All the columns are designed for minimum eccentricity, and you have to adopt the minimum eccentricity as 20 mm if the value is less than 20. Clear, my dear students? Is it clear, Amma? Now see here, 1 second, student.
Hello, sir.
Tell me.
Sir, is this first slide?
No, the first slide is this one. This is the second slide.
सर जो स्लेंडरनेस रेशियो सर जैसे हमने सॉइल में पढ़ा तो उसमें सर जैसे इफेक्टिव लेंथ डिवाइडेड बाय लीस्ट रेडियस ऑफ द
Yes, yes. Sir, actually slenderness has two things. One is effective length by least radius of gyration or least lateral dimension. Both are correct only. Okay. You can say or see, actually what happens is slenderness ratio, if you talk about, usually I also told you when I talk about the shape, L effective by R minimum. If you talk about the rectangular column, or in some other cases, we take least lateral dimension, effective length by least lateral dimension. Clear? Hello? Is it clear, student? In case, or you can simply say in case of rectangular column, you can take it. Okay. Now see, student, before, see, suppose we always told you what is a short column. When suppose in short column, we assume some assumptions. Remember, in any problem, we assume some assumptions. Why do people assume some assumptions, my dear students? Can you tell me? Remember, my dear students, why do you assume some assumptions in a call? Why do you assume some assumptions? Can you let me know? Sir, to make the complex problem into a easier problem. Suppose if you have 5 unknowns, you should develop 5 equations. But in this, if you assume some one or two assumptions, then there will be 3 unknowns. In that case, you have to assume 3. So always assumptions are made to make the complex problem into a easier problem. So here the first assumption, this can be an objective question in HPSC or any JE or AE exam. So the question here is the maximum compressive strain. The maximum compressive strain in concrete. 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 Okay. The maximum compressive strain in concrete is, can anyone tell me, subjected to axial load, what is the maximum strain in concrete in axial compression? Will be taken as what? What is the maximum compressive strain in concrete in case of axial compression? Can anyone tell me, my dear students? Very good, Amma. Very good. Very good. Who is that? Asim? Sir, Asima, are you very good, sir? Very good. Sir, actually, if you see the maximum compressive strain, if you remember, here it is 0.02, right? And here it is 0.0035. If you take 0.0035 means you are allowing maximum strain. So that is for LSM method. If you take about concrete, you will not allow more strain, you will allow lesser strain, that is 0.002. Now I have a question for you students. Asima, If you allow strain to 0.02, will it cost more or will it 0.0035 will cost more? Can anyone think in that direction? So the maximum strain in concrete in compression is limited to 0.002. If the strain is 0.0035, then in which case the amount will be more? Anyone please comment? Sir, you tell me for 0.002 case, what will happen? Very good, Asima. 0.02 case will have more cost because if the strain is more, that means you can allow some more failure. If the strain is very less, you have to make it more stronger. For that, you have to spend money. Simple thing. Very good, sir. Very good answer for everyone. Okay. The second example, so see students, here you have to underline the word, the maximum compressive strain in concrete in axial compression is 0.002. So you can write here, axial compression is 0.00. Agree students? Next, the second assumption here is, if I talk about the second assumption, the maximum compressive strain, if I talk about the maximum compressive strain, if I talk about the maximum compressive strain, in concrete, the maximum compressive strain in concrete subjected to, sir, this is only axial compression, subjected to axial compression, the maximum compressive strain in concrete subjected to axial compression and bending is, you can write here, is 0.0035 minus 0.75 times the strain in the least compressed extreme fiber. So you have to take here, it is 0.0035 minus 0.75 times the, sir, what is strain in the least extreme compression fiber? Suppose, see students, you might be seeing this is the strain, how it varies. Okay, suppose this is the extreme fiber. If they have to take, you have to take this value. What is that value? So 0.0035 minus 0.725 times that value will give you the maximum compressive strain in case of a column subjected to bending as well as the compression. Clear, my dear students? Clear? Is it clear, sir? So please remember this, students. The minimum eccentricity is unsupported length upon 500 plus least lateral dimension by 30. Okay. Next thing. Design criteria for short columns. What is the design criteria for short column? Sir, see, the first point I would like to tell you is all the columns are designed for minimum eccentricity. All the columns, design criteria for short column, all the columns are designed for minimum eccentricity. All the columns are designed for minimum eccentricity. Now see students, and minimum eccentricity should not be greater than minimum eccentricity. There is another condition also. The minimum eccentricity should not be greater than 0.05 times. The minimum eccentricity should not be greater than 0.05 times the lateral dimension. Should not be greater than 0.05 times the lateral dimension of the column. Now tell me, sir, what will be the ultimate load? Anyone, my dear students, can anyone tell me what will be the ultimate load? Suppose if you consider a column here, if I consider a column here, if I consider a 4 bars here, so what will be the ultimate load, sir? Load taken by concrete plus load taken by steel. Yes or no? How do you calculate the ultimate load here? In concrete, we have steel and concrete. So whatever the load which is taken by concrete is what, my dear students? 0.45 FCK AC plus what is the concrete taken by steel? Steel, sir, this is the stress of concrete and this is the stress of this is the area of concrete, 0.87 FY AST, right? Sir, actually it should be like, or ASC, area of steel in compression. But remember, my dear students, this formula is wrong. Actually, this formula is wrong. Why this formula is wrong is, for every column you are designing for minimum eccentricity. In this case, whatever the stress taken by concrete will be reduced due to eccentricity, and it will be equal to 0.4 FCKC plus 0.67 FYASC. So remember, this is the formula for the ultimate load, 0.4 FCK AC plus 0.67 FY ASC. Okay, what is AC is? AC is nothing but the area of concrete. AC is nothing but the area of concrete. AC is nothing but the area of concrete. ASC is known as the area of steel. ASC is known as the area of steel in compression. AC is the area of concrete and ASC is the area of steel in compression. So here you should understand here, students, one is 0.4 FCKAC, another one is 0.67 FC. Now this is the stress due to, now how do you find out area of steel of concrete? Sorry, area of steel in compression is total gross area. You can take this B into D, gross area minus area of, sorry, here I should write area of concrete. Area of concrete is equal to gross area minus area of steel in compression. Any doubts in this question, students? Is it clear for everyone? Okay. Now see, students, the same formula, this was asked in GATE exam, Amma. If the
सर जो
same
ये
formula,
AC
tell me.
AC वाला बताना सर कैसे?
Sir, AC is nothing but area of steel in compression, Amma. Suppose if you have a column like this, you will have steel bars, you will have steel bar, you will have steel bar, you will have steel bar like this. So total area means what you will do? What is the area of the circle? Suppose pi r square minus whatever the area of steel, you suppose it is 200 mm square or whatever. Remove that. You will get the area of concrete. That's what I am telling. Yes or no?
ये सर हमें AC दिया होगा कि हमें निकालना पड़ेगा इसमें जो ये फॉर्मूला आपने बताया?
सर एसी नहीं दे दिया, सेक्शन दे दिया और स्टील का दे दिया, वो दोनों सेक्शन का माइनस, दिस इज सेक्शन, सेक्शन आपका कॉलम सर्कुलर है तो उनके पास रेडियस दे दिया, और सेक्शन रेक्टेंगल है तो उनका सेक्शन दे दिया बीडी, बीडी दे दिया और स्टील भी दे दिया. नेवर दे गिव यू द एरिया ऑफ कंक्रीट. ओके
ओके सर.
Now, if we consider the ultimate design for zero eccentricity, or if the eccentricity is zero, if the eccentricity is zero, then in that case, ultimate load will be equal to 0.45 FCK into AC. This is plus 0.75 FY AS. Okay. This is due to concrete, and this is due to steel. Sir, here 0.75 is because usually we take the lesser yield strength. That is the reason. Yes, this is for truly axial loaded or with axial loaded with no eccentricity. You can say zero eccentricity, or you can say truly axial loaded, or you can say no eccentricity. Now see students, they can give you this question also. Suppose if the ultimate load of a column, rectangular column, is 100 kilonewton, what is the ultimate load of circular column? What is the ultimate load of circular column? What is the ultimate load of circular column? They can ask you. So in this case, usually in case of circular column, if you take the rectangular column in this way, circular column has more area, so definitely it will take more load. That is usually 5% more. So it will be equal to 1.05 into 100. That will be equal to 105 kilonewton. Are you getting me? This is how the question can also be framed up. Are you following, my dear students? So you can write here. You can write here. In case of, so you can write here. In case of circular columns, in case of circular columns or square circular column, in case of a circular column, in case of a circular column, the ultimate load will be taken as, sir, this is for minimum eccentricity, that is 1.05 into 0.4 FCK AC plus 0.67 FY AS. So here ultimate load is given by the formula what, sir? 1.05 into 0.4 FCK plus 0.67. So you can write ultimate load is equal to 1.05, or this example please take students, 5% load extra will be taken care by, 5% extra load extra will be taken by circular column. Will be taken by circular. Now see students, here there is a condition. See, for this circular column there should be a condition. Sir, Ashani Vani, please repeat, sir. Sir, what I want to tell you is, suppose C student.
Excuse me,
See,
sir. Sir.
tell
Hello,
me.
sir. Sir, am I
Tell me.
audible?
Yeah, you are audible.
Sir, actually, we have always studied that a circular column is 1.05 times stronger than the square column, or
Yes.
5%. So, how does it come existence? We could have taken it as 1.5 times, or whatever we want, as 2%. But why we particularly take it as 1.05 times than the square? Than the square column. That is, circular columns are 1.05 times stronger than
Sir,
the
this
square column.
wall, right? I got it. Why you are taking 5% more, right?
Yes, sir. That's what I'm
See,
about to say you.
actually, what happened with the column? No, if you take here C student, if you take a circle, okay, if you take a circle student, and if you take a rectangle here, or a rectangle or a square or whatever, suppose C student, if the radius is R, okay, what will be this length? Are you getting me? See here, the simple why it is 5% means they have done. See, Asha, what I would like to tell you is they will take a circle with different diameters. Suppose they will take a circle of diameter 30 mm, a column of 30 mm, or sorry, not 30 mm, 300 mm, or they will consider a rectangle of size, square column of size 300 mm, and they do the crushing strength and they compare the results. Similarly, they do with 400 mm, 500 mm. With this, if they do, they interpolate and they have observed that, if the load in case of circular column is 5% more. Are you getting me, sir? Suppose C students in sir, in IS 456, whatever the results which are yielded, all the results are yielded by taking a n number of samples. They, after collecting n number of samples, we have a institute called BIS, Bureau of Indian Standards, and they perform all the experiments and they will conclude that in case of a circular point, and one more point I would like to tell you. Suppose, see, sir, if you write a square column or a rectangular column, for your understanding, sir, the surface area of circle will be more compared to rectangle. That it cannot be like, suppose if I take a rectangle or a square, it cannot be multiplied 2 times. The circle area will not be more than 2 times. It will be like 5, like 1.5% or 1.2%. Based on that, they have observed that the strength is increased by 5%. Clear? Ashavani, did I answer someone, or Rohit, who has answered, who has asked the doubt? Did I clear? Am I clear, sir? See, students, see why load will be more. I'll take why here load will be more. Simple logic. What is load? Stress into area. Suppose if I take circular column, area of circle will be more. So by how use, and if I take the square, stress into area, it will have lesser. That is the reason. This is how the ultimate load will be more.
So, can we say that where square columns, circular columns are more stronger?
Can we say
That we have
circular?
minimized.
See,
So
student,
we have.
actually, you are going to sell Ashavani. Sorry if I am wrong in pronunciation, Ashan. What I would
So
like
no
to tell
worries,
you
no
is,
worries. Go on.
okay, I will tell you one thing. Suppose if it is a circular column, have you observed this? Suppose you went to a mosque. Will you see a rectangular column or a circular column? Just tell me. In general, I'm asking.
We are in malls.
Or any temples or anywhere in big
So
theaters.
circular columns
So
or
circular
whatever.
columns will have obviously circular column. The reason for circular column is it takes more load. See, if you are supporting a beam on a column, the surface area of the circle will be also more. That is the reason if you see in huge spans or home theaters or cinema theaters, mosque, church, temple, or anywhere where the public gathering is there, there you will observe circular column. But if you see in your buildings, like in your home, all those things will be rectangular column. If the loads are heavy, we go with the circular column. Agree?
Yes, sir.
तो
Agree.
सर्कुलर कोरम में जो हम मेन रेनफोर्समेंट बार्स होती हैं वो भी ज्यादा डालते हैं, 6 होती हैं
No,
और
no, no,
दूसरे
no,
में
no.
4 होती हैं।
Don't worry about Rohit. That is the next point I would like to tell you. Still, we have some codal specifications. Don't worry about how many columns are provided in hexagon, how many columns are provided in circular. All those things will be explained to you. Okay. Very good question, sir. I hope remaining students have understood that concept. Now, let us see what is the condition. Sir, here you are telling the ultimate load should be equal to 1.05 times the ultimate load of the rectangular column, right? So here, that is the reason IS code has given one condition. It should satisfy one condition. That condition is volume of helical reinforcement, volume of helical reinforcement, volume of helical reinforcement, volume of helical reinforcement upon volume of core, volume of helical reinforcement upon volume of core should not be less than 0.36 Ag upon AC minus 1 into FCK upon Fy. Sir, immediately again you will ask me, what is helical reinforcement, sir? Suppose if I take a circular column here, and if I see here, student, if I consider this as the steel bars, okay. So here what I would like to tell is, whatever the, see here, this is nothing but the helical reinforcement. Whatever I have showed it in the shaded part, this will be the helical reinforcement and this will be the volume of the core. Agree, students? Agree, sir? So he is telling that volume of helical reinforcement upon volume of core should not be less than 0.36 gross area upon area of concrete minus 1 into FCK upon Fy. So if your question Ashan, here it depends upon gross area, here it depends upon concrete area, and also the amount of steel, amount of concrete, everything it will depend. Clear, student? Is it clear, sir? Okay. Now see, students, next we have is the codal specifications here. The code specifications, students. Here we have a code specifications. So here, when I talk about the code specifications, what is the code specifications means according to the IS 456 code. If I talk about the IS 456 code, here, what does the IS 456 code says is the first one. This, sir, every point according to IS code can be an objective question in your AE exam or JE exam. Here the question is the minimum percentage of the minimum percentage of the minimum percentage of longitudinal reinforcement, the minimum percentage of longitudinal reinforcement is 0.8% of gross area. How much, sir? 0.8% of gross area. The second point I would like to tell you is, sir, maximum reinforcement is given as maximum reinforcement is 6% of gross area. Maximum reinforcement is how much, sir? 6% of gross area. But remember, sir, actually, my dear students, why do we use helical reinforcement, sir? Tanvir, that is also a very good question. Actually, see, students, If you take a column, okay, actually most of the people will go with the actually with the because as there are no means proper skill labor, usually people will go with the rectangular or square stirrups. But what's helical reinforcement means? See here, what do you mean by helical reinforcement? If I talk, sir, see, when I talk about the helical reinforcement is the same thing, Amma. Whenever you talk about the helical reinforcement, the advantage here is the area, how much area it is going to cover. The area it is going to cover is more, sir. Suppose if you provide a helical reinforcement, the thing is that if it is rectangular, it can cover lesser area. But if it, the helical reinforcement means it covers more area so that it holds the concrete together. Are you getting me? Just visualize that, sir. Yes, yes, very important. Sir, actually, helical reinforcement, actually simple thing, Amma. I'll tell you. Suppose there are 6 bars. Sir, actually, we have there can be a project also have been done. Suppose if you see there are 4 bars like this. If you provide helical reinforcement means they will be tied together. So here that is the reason helical reinforcement will have obviously more strength. But remember, students, helical reinforcement we require skill labor and at the same time it is more costly also. In earthquake prone areas, Neena Rashid, it is absolutely correct, sir. Actually, in India, we have classified the zones into zone 1, zone 2, zone 3, zone 4, and zone 5. And if the whatever the buildings which are falling under zone 1, where there is more severity, definitely we go with the helical reinforcement. Okay. But if you see in the areas where there is no earthquake prone or it is okay, seismic, earthquake, everything is same. Tanvir, fine? Now, see, sir. Sir, actually, what I would like to tell you here is you have mentioned that the maximum reinforcement is how much, students? You have told it is 6% of gross area. But for your information, students, but for your information, what I would like to tell you is even though the code says it is 6% of gross area, it cannot be more than 4% practically. But practically, code, what does code says is 6%, but practically it cannot be more than 4%. Simple logic, my dear students, when you provide more and more steel, then the brittleness also will increase. Agree, my dear students? Okay. Now, there can be another question also asked here. The other question here is, what is the minimum size of longitudinal reinforcement or what is the minimum size of bar used in reinforcement, my dear students? See, as I told you previously, we are using the Fe250, that is mild steel, but nowadays no one is using Fe250 grade of steel because the Fe250 of steel can be manufactured from recycled iron. So that is the reason no one is using the grade of Fe250 and heavier one is using the high yield strength deformed bars. So the minimum size of bar in longitudinal section in column is how much, sir? It is 12 mm. So please remember, sir, the minimum percentage of tension reinforcement is 0.8, maximum is 4%, 6% of gross area, and minimum size of longitudinal bar is 12 mm. Sir, you will ask me, sir, in slabs you provide 8 mm, but why you are providing 12 mm in case of a column? The necessity to provide 12 mm is to avoid or to avoid buckling of bars. To avoid buckling of bars, if you use higher dia, then definitely you can avoid that buckling of bars. So you can write here the minimum size of bar is 12 mm to avoid the buckling of bars. To avoid the buckling of bars. Okay. The next concept I would like to tell you is what is the minimum number of bars? See, students, when I talk about the minimum number of bars, what are the minimum number of bars in different section? Sir, in JKSSB, there are 2-3 times they have asked, I think HPSC also. How many minimum number of bars are there for circular? It is 6 some. And if you talk about the circle or hexagon, hexagon means X, which is having 6 sides. In this case also you can write it is 6. 6. Okay. So what is the number of bars here is 6. When you talk about rectangle, it is rectangle or square. Here you can write Here it is circle, hexagon, and here it is rectangle or square. It is in case of rectangle, or square. In case of rectangle or square, this will be equal to 4. This will be equal to, so this is 4, this is 6. So they can ask you what should be the minimum spacing is. The minimum spacing or spacing, not minimum spacing, I should say spacing of bars should not be greater than, or spacing of main bars or spacing of bars should not be greater than what, sir? Should not be greater than what, my dear students? Can anyone explain? Spacing of bars should not be greater than 300 mm. As I told you, it cannot be also not. If you see in shear reinforcement also, I have told you 300 mm. Very good, very good. Okay. If they ask you what is the minimum percentage of longitudinal reinforcement, they can ask you this also. No? The minimum percentage of reinforcement. The minimum percentage of reinforcement. The minimum percentage of reinforcement in case of pedestal. In case of pedestal is, so what is a pedestal means? This is a column and this is a pedestal, and here we have the footing. So this is entire thing is pedestal. So the minimum percentage of reinforcement in case of pedestal is, you can write it is 0.15 percentile of gross area. Sir, what is AG means? AG is nothing but the gross area. AG is nothing but what, sir? AG is nothing but the what is AG, student? So here I would like to tell you, my dear students, here what I would like to tell you here is the minimum percentage of reinforcement in case of pedestal. Students, what I would like to tell you here is the minimum percentage of reinforcement in case of pedestal is 0.5 percentile of gross area.
सर जो स्पेसिंग बार में आपने बताया कि 300 mm से ज़्यादा नहीं होनी चाहिए सर, ये
Yes.
तो सर जैसे लॉन्गिट्यूडनल रेनफोर्समेंट के लिए हुई, अगर हमने स्टीरअप्स की देखनी हो तब भी इतने ही देंगे हम?
Sir, I'll tell you, sir. Rohit, please be calm, Amma. We have a concept called pitch of lateral dia. I have not completed that. I want to tell you. Let me complete that and you can ask that, Rohit. That is the next point I would like to tell you. I'm not done. Here we have to talk about the whatever the pitch of diameter of reinforcement and helical reinforcement and all. Okay? Rohit? Fine. Okay. Sorry. It's okay. No, sorry. So here what I would like to tell you here is the next concept I would like to discuss here is the pitch. Sir, what do you mean by pitch and gaze? Anyone, my dear students? First of all, leave about RCC or anything. What do you mean by pitch and gaze? So when I talk about the pitch and diameter of lateral ties, when I talk about the pitch and the diameter of lateral ties, what do you mean by pitch and diameter of the lateral ties? See, students, here I would like to tell you one important thing. Suppose if you have see, whatever the spacing in the direction of force, this is known as pitch. Suppose if you have a bar here, if the force are this way, perpendicular to the direction of force, this is known as gaze. Sir, pitch and gaze depends upon the direction of the force. Okay. Suppose here I would like to tell you one important thing. Here, what is the important thing I would like to tell you is pitch should not be more than, or should not be more than, or pitch should not be more than, you can write not more than or not greater than, this indication. should not be greater than least lateral dimension of the compression member, least lateral dimension of 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 compression member. One is the least lateral dimension of compression member, and another important case is it should not be greater than 300 mm, as I told you. Sir, least lateral dimension of compression member means, you know, right? If I take the compression member, this is A and B, whichever is the least, or should not be greater than 16 times the minimum dia of longitudinal reinforcement. Minimum dia of longitudinal reinforcement. See, students, always remember the main 16 times the minimum dia of longitudinal reinforcement. So here, my dear students, I would like to ask you one important thing, Amma. Sir, I have asked some question, I forgot. Can anyone tell me? I have asked some question to you. Sir, here pitch should not be greater than least lateral dimension 300 mm or 16 times the minimum longitudinal reinforcement. Okay. Gauge and pitch I have told you, no. Gauge is the spacing between the bars in the direction of force. This is pitch. The distance between the bars perpendicular to the direction of force. Okay. So here this is known as pitch. Next one I would like to tell you here is the diameter. Sir, whatever the diameter which is they are using. Repeat, sir. Sir, what I am telling you is, suppose this is a bar, amma. This is a steel plate. We have two bars here like this. Okay, if there is a force here in this way. Okay, the distance between these two will be pitch, and the distance between these two, this will be gauge. This will be gauge. That's what I would like to tell you. Clear, sir? So here, whatever the bar diameter, what I would like to tell you is diameter should not be less than 1/4 of this is for tie, dia of tie should not be less than 1/4 dia of largest bar used, and it should not be less than 6 mm. Sir, you are telling it should not be greater than this, means out of these three you should take the least value. If they tell you it should not be less than, means you should take the maximum value. Yes or no? Am I correct or wrong, sir? Next. Next I would like to tell you is helical reinforcement. Next I would like to discuss here is the helical So here when I talk about the helical reinforcement, see here in helical reinforcement the pitch should not be greater than 1/6 of students. Are you following, Amma? Okay, in helical reinforcement pitch should not be greater than 1/6 core dia of 1/6 core dia of 1/6 core dia of column should not be greater than 1/6 dia of the core column, or should not be greater than 75 mm, or it should not be less than how much, sir? In case of pitch, it should not be less than 25 mm, or it should not be less than 3 times the dia of the steel bar, 3 times the dia of the steel bar used for 3 times the dia of the steel bar used for 3 times the dia of the steel bar used for helix. Sir, what do you mean by helix? 3 times. Suppose whatever the bar which you will bend in this way, this dia of bar is telling. So it should not be less than 3 times the dia of the steel bar used for helix. And what is the minimum cover, students? What is the minimum cover for column? What is the minimum cover for column? Anyone? What is the minimum cover for column? What is the minimum cover for column, sir? The minimum cover for column is 40 mm, and it might be increased due to the adverse conditions. Okay. Sir, next slide, Amma. If you don't get this question from the next slide, which I am going to tell you, then immediately call me. You will definitely get these questions from this code. But next slide is very important. Sir, see, in strength of materials, you might have studied about the effective length. Sir, see, both ends are fixed. What is effective length? They can ask you. Sir, if you see in strength of materials, what is the effective length, sir? This will be the effective length. In case of strength of materials, it will be L by 2. But in case of, according to IS 456, it will be equal to 0.65 L. If I consider this as length of the column, the effective length will be taken as, this is known as L effective. And this will be taken as how much, sir? 0.65 L. And most of the students will write wrong, because in SOM, you might have studied it as 0.5 L. But according to the IS 456 code, my dear students, this value is equal to 0.65 L. According to IS 456, this value will be equal to 0.6 L. Right, my dear students? Now, when I talk about the effective length, in case of one end fixed, other end hinged, in case of one end fixed and other end hinged, In case of one end fixed and other end hinged, you can say this is, you can write here both ends fixed. Both ends fixed. Here you can write, my dear students, one end fixed. Here you can write one end fixed, one end fixed, other end and other end. One end fixed and other end hinged. When you talk about one end fixed and other end hinged, in this case, the effective L effective will be equal to 0.8 times L. It will be equal to how much, sir? 0.8 times. Okay. And if I talk here, when both ends are hinged, actually if you talk in, this will be 0.5 L in SOM. If you talk in SOM here, it will be equal to L by root 2, that is 0.707. All these are SOM, but when both ends are hinged, here when both ends are hinged, then effective length will be equal to L. Effective length will be equal to L. And one end fixed, other end free, it will be equal to 2L. One end fixed, other end free, it will be equal to what, sir? 2L. You can write here one end fixed. When one end is fixed and other end free, then L effective will be equal to what, sir? L effective will be equal to twice the length. Any doubts until now, students? Can anyone, any doubts? Now see, sir, they can, I'll give you one of the example also. They can ask you like this also. In one of the IES exam, they have asked it, sir. In a way back 2002 or somewhere, what the elements that are, the elements that are normally subjected to, the elements that are normally subjected to, the elements that are normally subjected to, the elements that are normally subjected to combined bending, the elements that are subjected to combined bending and axial force. And axial force. The elements that are normally subjected to combined bending and axial force, you can take the example as, what, sir? Can anyone tell me? The example can be taken as columns in a framed structure. Columns in a framed structure. Columns in a framed structure. This is the best example, the elements that are subjected to bending and axial force. For this, I will tell you one important thing, Amma. Just for your practical observations, I will tell you one important thing here. Suppose if you have a plan like this, okay, and here you can have columns like this, right? Have a columns like this, assume. Now see, sir, if a load is applied in this way, and this column, if I take one, this will be subjected to what, sir? This will be subjected to axial compression. If you see this column 2, 3, 4 and 5, these will be subjected to uniaxial moment. Compression plus uniaxial moment. If you take these columns 6, 7, 8, 9, they will be subjected to axial compression plus biaxial. Agree or not, students? Is it clear, sir? Sir, movement in both the directions. Then somebody is playing the guitar in the background. Tanvir, okay. They will stop it. They will stop it. Okay. So biaxial. So you can say biaxial movement. When it is subjected to axial compression and biaxial movement, then it is called as. Fine, sir. Students, it was late. Actually, I just arrived at my home now only. So I'll continue tomorrow. I don't want to cancel the class for today. That is the reason I have taken for 1 hour. So please bear for me. Tomorrow I'll take the class in the morning. Okay. Thank you. And try to, sir, most of the people of JKSSP or any student, they try to read more, sir. They try to read more. But based on the exam, you have to prepare. If you are preparing for GATE exam, you have to prepare more of complicated questions. If you are preparing for state level exams, it should be more of objective. So from exam to exam, the preparation varies, sir. So don't think that if you keep on reading some extraordinary things, you will not get that, and ultimately you will be in a dilemma. So that's what I want to tell you. So here, see students, if you see the first column will be subjected to axial compression. 3, 4, 4, 5, 2, 3, 4, 5 are subjected to axial compression plus uniaxial moment, and 5, 6, 7, 8 or 9 subjected to biaxial moment. Sir, if you see the movement in one direction, then we call it as uniaxial. If the movement in both the direction, then it is called biaxial. Okay, sir? Okay, thank you everyone and good night. And tomorrow we'll start the session at 6:30 am. Okay, with the tomorrow's notes and today's notes, I'll send you the entire notes. Okay, thank you. Sir, show the first slide. This is the first slide.
सर जैसे हर लेक्चर की अलग अलग पीडीएफ भेजी है सर, इसकी कंबाइन मिल सकती है सर, जैसे हर चैप्टर की, जैसे टॉपिक वाइज जैसे आपने भेजी है अलग अलग ना?
Yeah, I'm doing that only. Actually, today only. That is the reason I'm telling you. If I complete tomorrow, entire column will be completed. That is the reason I will send you the notes tomorrow. I told you. Are you getting me?
जी सर.
Yeah. Asha Vaini, that is the one of the reason I have ended the session, sir. Okay. Actually, Asha Vaini, that is the one of the reason I have ended the session, and I'm outside. Actually, I don't want to break the session. Actually, today traffic is very high. Tomorrow I'll be conducting the class on time. Okay. And Nena Rishit, that I'll do definitely. Okay, that I'll do. Don't worry about this. Thank you.